So here I've uploaded my MATLAB code and have the graph here on the left. As far as what I think about the data that came from it, I would say that for the most part, the RC circuit with a 10 kilo ohm resistor would be usually more useful as a sensor in those terms, because it reacts a lot quicker. The time constant is a lot smaller, so you can get data quicker. I have the yellow hooked up to A1 as the read for VN. VN is connected to the digital output, so it's receiving 0 or 5 volts. The green wire is hooked up to A0, that's the voltage across the capacitor, and then the voltage is connected to ground. As you can see here, here's my code. It's commented to read in the code section, but basically there's the delay to print every tau over 50 seconds, and I built in a delay with the for loop 500 here. 500 iterations equals 10 tau seconds, so it holds high for 10 tau seconds, holds low for 10 tau seconds, and reads throughout. Here you can see my readings as the input voltage readings get higher. You can see that the capacitor maxes out. You can see here I switched out the 10,000 ohm resistor for the 100,000 ohm resistor, and I just changed that in my code here. Everything else is the same, and here you can see my results. So as you can see here, I have my table here labeled with 0 through 5 volts with the legend at the bottom. This is for the 10,000 ohm resistor, so you can see it meets up with the 5 volts just at the end of the time, and then goes down to 0. I'll explain my code here real quick. So I have basically set up the graph with creating lines. I just found where it was 0 and found where it was 5, and then I divided the difference of that by 5 to get the location for the rest of the lines. Made the text size big so you could see the voltages large enough. I just put the text at those locations slightly above the line. Then at the bottom I made the legend, so I changed the fill color and then placed the ellipses appropriately next to the VN and VC labels. The only other thing I changed also was the serial port, which was 2 because mine comes out of COM5. And also the baud rate.
And here is the plot for the 100,000 ohm resistor.
So here you can see my code for the MATLAB portion. Here's the getting the data from the 100 kilo ohm processing file. There's a scaling factor here to get the ADC to volts, which is just 512 divided by, or 5 divided by 512. And then the only other thing I changed is the scaling of the axis down here, just to get it within the voltage range. Here's my 100 kilo ohm data. It does match up with the original one fairly well. Like, the time constant is much longer than the 10,000, which I'll show in a second. Here's my figure for the 10,000 ohm resistor. As you can see, the time constant is much shorter, and it just about reaches 5 volts before discharging again. So here's my Arduino code for the thermistor code. As you can see, I just left the time constants up there from the previous and just left that as the delay, just for simplicity. However, the difference here is that as the temperature goes up, resistance in the thermistor goes down, meaning that the voltage across the thermistor becomes smaller and smaller. So I have 1023 minus the analog read to make the graph actually go up when the temperature. Quick side note, I actually had to use a different thermistor because I never got one in my package, and one was mailed to me but it never got to me. So I'm using a different one, but here I put a lighter on the thermistor, and you can see it skyrockets up. We're recovering from the lighter, but I'm going to put a bag of vegetables, frozen vegetables on it, and you can see it goes down much slower because the temperature difference is much less. However, you can see it's going down pretty quick. Finally, just one last note. I did say I had to use a different thermistor. It's a 10K thermistor, but I think it behaves much more exponentially than the other thermistor that we were given, and also the range is a little bit different. That's why I have 150 degrees Celsius to negative 40 degrees Celsius.